Hello everyone, my today's topic of discussion is permanent magnet moving coil type instrument. In short, it is known as PMMC type instrument. In this lecture, I will cover about the construction of the instrument. I will discuss about the different components of the instrument and the function of the different components of the instrument. So the PMC type instrument, basic range of this type of instrument is within the range 10 microampere to 100 milliampere. Resistance of the coil which is used in this PMC type instrument is within the range of 10 ohm to 1 kilo ohm. Application of this type of instruments are DC ammeter and DC voltmeter. This instrument is used only for DC measurement. It cannot be used for AC measurement. Power requirement for this type of instrument is within the range of 25 microwatt to 200 microwatt. Accuracy of this type of instrument is within the range of 2% to 5% of the full scale deflection. So I will discuss about different component of the instrument and function of the components one by one. It has external magnetic shield, permanent magnet, moving coil, control spring, pointer scale arrangement for zero balance of the pointer. This is the 3D view of the internal parts of the PMC type instrument. It has permanent magnet, north pole, south pole of this permanent magnet. Within this north pole and south pole there is a free space. Within this space a soft iron cylindrical core is placed. The function of the permanent magnet is to produce the deflecting torque. Here deflecting torque is produced due to the magnetic effect. And the function of the soft iron core is to intensify the magnetic flux. So to intensify or to increase the deflecting torque, this soft iron core is used. Over the soft iron core, moving coil is placed. On a aluminum former, rectangular shape aluminum former. The former shape may be rectangular or may be circular. So if the moving coil is circular in shape, then the soft iron core is spherical in shape, and if it is rectangular shape, then the soft iron core is cylindrical in shape. The moving coil is attached with the spindle. Here you will get a better view of the internal parts. The moving coil is attached with the spindle. The spindle is supported by pivot and jewel bearing. The moving coil is made up of multiple numbers of fine wire. The wire is made up of copper. So when current is flowing through this moving coil, there is some deflecting torque is generated over the moving coil, and due to the deflecting torque, the moving part rotates. Control spring is used to produce the controlling torque. Here two control springs are used. Two phosphor bonds hair spring are attached with the spindle. One is above the soft iron cylindrical soft iron core. Another one is placed below the soft iron core. When the pointer rotates or moving system rotates, these two control spring compressed, and some restoring force or controlling force are generated by the control spring, and which is acting in opposite direction to the movement of the pointer. So pointer and scale arrangement is there. Instrument is calibrated in terms of the current if it is an ammeter, and if it is the scale is calibrated in terms of voltage if it is voltmeter. For PMC type instrument, the scale division is uniform because the angle of deflection theta is proportional to the current I. If I current is flowing through the instrument, then angle theta is proportional to the current I. External magnetic field, see this working of this instrument is depending on the magnetic field, magnetic effect of the permanent magnet. So if the instrument is placed nearby near any other magnetic field, the external magnetic field will affect the working or operation of the instrument. Means there will be error, proper reading will not get, and it will not show the exact value, will show the accurate value of the measurement. So for that reason we have to use some magnetic shield. So magnetic shield is provided outside this instrument, and it will bypass the effect of external magnetic field. Arrangement for zero balance of the pointer. The arrangement for zero balance of the pointer is required because when the instrument is not in operation, the pointer comes to the zero position. Sometimes it is observed that the pointer is not exactly on the zero position, it is displayed some little bit. So to keep the position of the pointer on the zero position, some arrangements are there. This arrangement is very required because if it is not present there, there may be some error in reading. So that's all for today's lecture. In the next lecture I will discuss about the deflecting torque, how the deflecting torque is generated, derivation of the deflecting torque of the PMC2 instrument. Thank you.